Bn using the formula Bn equals 2 by n pi a integral 0 to L g of x sin pi n x by L into dx, where g of x is defined in two function definitions applicable to two interval 0 to L by 2 and L by 2 to L. Therefore, we will split the integral 0 to L as 0 to L by 2 and L by 2 to L. In the range 0 to L by 2, we will have g of x equals cx by L, and in the interval range L by 2 to L, we will have g of x equals c by L multiplied to L minus x. Hence, Bn is obtained in this way, and we will take c by L outside the process of integration from both integrals because c by L is just a constant. Now we will perform the integration for both integrals using integration by parts. Here, first function is written as it is. Sin pi n x by L is integrated to obtain negative cos pi n x by L divided by pi n by L minus derivative of first function with respect to x is 1. Integral of negative cos pi n x by L upon pi n by L is obtained as negative sin pi n x by L divided by pi n by L whole square, because integral of cos pi n x by L equals sin pi n x by L divided by pi n by L. Along with, we multiply this negative sign and pi n by L which appears in the denominator, and hence we get this term. Next time when you take derivative of first function, it becomes 0, and you can stop integration by parts applicable for this integration. Now we will perform integration by parts for this integral. First function L minus x is written as it is, and integral of second function gives us negative cos pi n x by L divided by pi n by L. We have derivative of L minus x, which is negative 1 written here, and integral of cos pi n x by L equals sin pi n x by L divided by pi n by L. This negative sign is written here. Pi n by L gets multiplied along with the denominator, and we get the term as negative sin pi n x by L divided by pi n by L square. Next time when you take derivative of first function, it becomes 0, and we will stop the process of integration by parts here. You can take denominators pi n by L and pi n by L square to numerators correspondingly as their reciprocals, and thus we get Bn equals 2c by pi n al multiplied to negative Lx by n pi cos pi n x by L plus L square by n square pi square sin pi n x by L, to which we will have to give upper and lower limits L by 2 and 0, plus negative L by n pi L minus x cos pi n x by L minus L square by n square pi square sin pi n x by L, to which we have to give upper and lower limits L and L by 2. This constant term is applicable to these two terms or these two square brackets completely, and that's why we have used curly brackets here. When you give upper limit L by 2 to these two terms, you can see that this term becomes negative L square by 2 n pi cos pi n by 2, because when you give x equals L by 2 here, this pi nx by L becomes pi n by 2. Similarly, this term becomes, when you give x equals L by 2, L square by n square pi square sin n pi by 2. You are giving upper limit x equals L by 2 only here, and this complete term pi nx by L becomes n pi by 2. When you give lower limit x equals 0 here, it becomes sin 0, which is 0. When you give x equals 0 here, again this term also becomes 0. Therefore, lower limit is giving us only 0. When you give x equals L to these two terms, you get this term becoming 0 when you give x equals L here, and when you give x equals L here, it becomes sin n pi, which is 0. Applying the upper limit here in this square bracket, it becomes 0 completely. Now we will give x equals L by 2, which is the lower limit, so that these two terms become negative L square by 2 n pi cos n pi by 2 minus L square by n square pi square multiplied to sin n pi by 2. We have a negative sign here because we are applying the lower limit. Here we have negative into negative, this term becomes positive, and it gets cancelled with this term negative L square by 2 n pi cos n pi by 2. Thus we have L square by n square pi square sin n pi by 2 plus L square by n square pi square sin n pi by 2, because when you multiply this negative sign along with this negative sign.